Now we will investigate the evaluation card that is provided for the netX 90. This is the NXHX 90-JTAG. It has several uses. First of all, as a reference design. This is an example implementation that you can copy over to your own use. For schematic design, it's good as it is. However, someone using or wanting to lay out this board needs to be aware of any temperature and EMC environment considerations that they might need for their own board. Secondly, a reference board can be used as an external host to try out companion mode use cases. Headers are provided to extend the dual port memory bus to an outside computer. And finally, it can be used as a software development platform. It has an onboard debugger coupled with netX Studio, the integrated development environment that we've mentioned previously, and all of the tools that you need to support the composition and debugging of your application code. The evaluation card is well documented in the NXHX 90-JTAG user manual. Let's briefly look over some of the interfaces that are available to you. The first interface we're going to talk about is a communication interface that is made available for Fieldbus protocols. By Fieldbus protocols, I mean protocols that do not use an Ethernet media. For instance, DeviceNet, CAN, Profibus, Serial, all of those protocols can be supported on this particular header using extension boards that are provided by Hilscher. This next connection is where the dual port memory can be extended off the evaluation card so that it can be connected to say the evaluation card of your local microprocessor or another computer or something that you want to connect as a host to this part. This is where you can make that connection to the outside world and extend the dual port memory outside. This is what's needed for the use case that were called companionship modes. This next header is for an RS-232 port. Again, we have accessory cards that will fit on that header and will make available a full RS-232 implementation. Likewise, we have another board that will do an encoder, a specific implementation just for encoder options. Analog to digital interfaces for the NX 90 are available here. Debug has both an onboard debugger with a USB port as well as a full JTAG connector. We also make available certain IOs that you can use for your own experimentation, 4-dip switch and 4 LEDs that can be driven from the general purpose digital IOs on the netX 90. And finally, we have the host interface. The host interface is a standard Hilscher interface that it makes available several accessories like external SD-RAM, and also an extension to a PCI bus so that you can use a Windows-based machine with a PCI card as an interface to develop software on this particular part. Here we describe some of these peripherals that I've mentioned in the previous screen. The communications bus, external bus here, has these particular modules. As we mentioned, these are all protocols that do not use Ethernet as their media. Profibus, CANopen, DeviceNet, and CC-Link, all accessories that will connect on that header. And for the host interface, we have several devices that are made available. This device will make available the dual port memory on a SPI bus as well as external SD-RAM. This device here, the NXPCA PCI, is the parallel dual port memory interface to a PC, as I mentioned before. It uses a ribbon cable to connect from your PC to this particular board and allows you to use the PC for development. And then finally, the interfaces that we mentioned before for RS-232 and for the encoder are made available as the NXHX-RS-232 or NXHX-ENC.